Pretty prints with persistent peculiarities. Nylon nightmare. Settings seem sensible. Suggestions go sideways. And Prusa's printing power chords. You'll figure it out. All this and more, PrintFix Friday, episode 231. Let's get into it. Diving deep here with layer problems on two machines. We've got a couple of P1S printers, and the parts look objectively pretty darn good, but they don't, right? This, to me, is kind of an acceptable amount of banding. That is very much not an acceptable level of banding. So we've got something here that is wiggling, or we are ever so slightly over extruding. If we look here, we've got ridges. What do we say here on the channel? If your ruffles have ridges, on your first layer, you're too close, but you're over extruding. If you are on layers anything above 5 and you see your layers with peaks like that in between them, right? We can see it on pretty much every single top layer here. You are over extruding. I would cut the extrusion here by like 1%. And heck, you can even do it in the middle of the print. Run this test again. And like, I don't know, after the first 2, drop it 1%. Go another 2, drop it another 1%. I think this could be over extrusion, but this is screaming to me like we've got another problem. Now, this could be a factor of which direction the nozzle is traveling at that time. So if you have some layers where it's going clockwise versus anti-clockwise, this could be causing that shifting as well. And because there's just extra pressure toward the end, it's falling out of, the loop as it was. But I do want to check to make sure that everything is kind of nice and tidy, right? Touch the belts on both sides. So kind of put the X carriage in the middle, the Y carriage in the middle as well. And then just touch the belts. Do they feel as though they're roughly the same tension? If they do, then that's probably not the problem. But if one feels significantly more taut than the other, let's fix that. Now, which one is too tight and which one is too loose? Can't tell you. That's going to be all about trial and error. I would say average amount, you'll probably be all right. But when it comes to Core XY machines, they want to be very close to the same belt tension for each of the XY belts because of the way that Core XY motion systems work. There's a graphic right here. It's kind of weird, but it means that the pulling forces are pretty much negated on this because as one is pulling, the other is kind of pushing, but it's letting out material. So your forces are more controlled than it is in a Cartesian-based system, if that makes sense. This is not consistent enough for me to say it's Z-banding, but you could clean the Z lead screws. If you want, you can re-lube them if you want. The thing is, though, you've got two machines of very varying ages, one being a few years old and the other only a month old, and they are using Bambu filament. In my personal experience with Bambu branded filament, it is not pure. That's why it often prints much faster than other brands, because it has a lot of fillers in it that allow it to go fast. Yes, your high-speed PLAs are actually less PLA than the regular PLA that you're used to, and often the PLA Plus that you pay extra for is, in my experience, closer to normal PLA than the high-speed PLA that you're buying. I hate that manufacturers do this, and it upsets me. And it's why we recommend that you buy from trusted sources. Polar Filament, Printed Solid, those companies, those are both made in America, okay? You've got Atomic, 3DX Tech, Push Plastic. There's tons of others in the States, and you can find smaller manufacturers near you that will sell you known pure materials. And if they're not pure, they'll tell you that, and you don't have to assume that these materials are going to be pure when they're not. Now, I don't think that has any impact here, to be clear, but it's not important, right? It's good that we know what we're making our parts with, especially if you want to get into doing this as a business. Jacob and I have recently been talking about the business side of 3D printing in our podcast. We'll card to the most recent episode so you guys can take a watch. A lot of that comes down to knowing your factors and knowing your variables. The more variables you can control as a business owner, the better. What is in your freaking filament should be one that you should easily be able to, deal with. Because if you can't, then who's really in control of it? I would look at reducing my extrusion multiplier ever so slightly and then see where that goes. I know this can be a common issue on high-speed machines as well, so you might want to look to lower those outside perimeters, but again, one step at a time. Let's lower that extrusion from 1.0 to 0.99 first and see how that runs. Start with that because it does appear that you are over extruding. Look to get a nice flat surface, especially if you are not ironing your parts. If you iron your parts, it kind of ruins the entire thing. But if the top layer of your print feels like it's got a bunch of ridges in it or it's got valleys in it, you got to work on your extrusion multiplier and get that figured out. Let me know your thoughts. I think it's over extrusion. Every now and then we all over extrude, and sometimes we under extrude. But my name's Grant. This is 3D Musketeers PrintFixFriday. We hope you get your printers back to printing with purpose. Reach out if you need help. Links down below. We can help you out. Film a video. Tag us in it. I don't know. Let's have some fun. Just like Azzy Design Works did here, who is printing some Fiberon PA612CF15, what I can tell, because I don't see it coming in a 13, with 0.6 diamond back on a prepped bed, 35C bed, 281st layer, 0.34 height, which is pretty deep. Flow rate is 1.1, tuned from the Voron 2.4 wiki reference. Infill first layer speed is 50 millimeters second. Walls are 40. Bed leveling shows a max 0.26 deviation. That's a lot of deviation. Printing from Prusa slicer for better results. SV08. Too fast, more heat. Seeing if we can weigh in on PrintFixFriday. And yes, we can absolutely weigh in on PrintFixFriday. The first thing that I would instantly go to is, my God, that is a cold bed. It's nylon. Freaking nylon wants to be hot. But when we go to the Fiberon page on Polymaker, they see bed temperatures between 40 and 50 and printing temperatures 250 to 300. And you don't need a chamber or enclosure. This isn't nylon. Like, it might be a nylon blend, but it's not nylon, right? Nylon wants to be very hot on the nozzle, about, 300 C, very hot on the bed, like 110 Celsius, and the hotter the chamber you can get, the happier it will be, up to like 130 Celsius or so. So this doesn't make a lot of sense to me. I trust Polymaker on this one. We've actually visited their R&D facility in Changshu, China. The video is not out yet, but if you are in our Patreon Discord, you've actually seen some behind the scenes from it when we toured there a few months back. It's a really cool facility. You'll see a video on it relatively soon, so get subscribed if that's your kind of thing. But minimally, obviously, let's raise that bed temperature a little bit. The 1.1 flow rate to me is a bit of a misnomer. I think we might be a little bit too close to the bed for this, and that's what's potentially causing our problems. Now, 0.6 Diamondback, I don't have any qualms about that nozzle. I know that thing's gonna run until the cows come home. But a 0.26 millimeter deviation on the bed seems really, really high. More than I would want to see for something like this. I know the SV08s are not known for having a metrology flat bed, but 0.26 is a big deviation. And further, I know you like using Prusa Slicer, but for any clipper printer, we're pretty much switched over to Orca Slicer here in the shop. We really only use Prusa Slicer for the Prusa machines anymore, but hey, your mileage may vary. I would take that flow rate back to 1.0. I would turn your bed temp up, and I would turn your nozzle temperature up to maybe 285 or 290. I wouldn't be doing all these pieces at once. I understand you have a big bed, and hey, I like big beds, and I cannot lie. You other brothers can't deny. I think that the skirt here could have told you that there was going to be a problem. We can definitely see some issues there. I understand that you don't want to put glue or anything on it. This to me is a perfect time to throw down some nanopolymer adhesive from Vision Miner. We'll link to some down below. We love NPA here, been using it extensively lately for PETG. And the nice thing is when you're not running high temp materials, it lasts a long time. It lasts like 15 or 20 prints so far that we can see before it does start to lose some of its sticktivity. But it would absolutely help this when you have the bed at a slightly higher temperature. I'm still confused as to what makes this nylon print at such a low temperature. And while I couldn't find a perfect analog over on 3DX Tech, if we look at their nylon 12, they're recommending extruder 265 to 285, bed temp at 90 to 110, with heated chamber being recommended, and their nylon 6 CF with the exact same stuff, right? 265, 285, 90 to 110, heated chamber recommended. So something is different here. Now the cool thing, and give credit where it's due, we've got most of a TDS sitting right here, technical data sheet, with our heat deflection temperature, our dry and wet Young's modulus, depending on, you know, the material itself. We've got our strength, dry and wet, our Charpy impact strength, as well as our bending modulus. Like, these are all really useful to have, and don't get me wrong, if you are looking to do parts out of nylon, not a bad place, but I'm sorry, as someone that works in the aerospace industry, and look, I like Polymaker. They're good friends of the channel. This is not an aerospace grade material. You can't certify it because it's clearly not pure. These temperatures are way lower than you would expect them to be. So there's something in here. Low moisture sensitivity, that's not what nylon is. We literally just talked about having pure materials. This is another perfect example of like, okay, sure, it's gonna have better adhesion than a PLA or PETG or ABS or ASA, but is it pure nylon? The math doesn't math for me. What do you all think down below? But minimally for this, I would go ahead and try a little bit hotter on that bed. It's not gonna really change the major issue that we have, but what I am noticing is that it's a really consistent issue on these. Like where you can see the dragging, right? It looks like you're a little too close as well, but check that carriage and make sure nothing is loose on that carriage, because as it might be going in a different direction, it might be getting rocked. I recognize that it is a ball bearing carriage and not something with V-wheels on it, but that doesn't mean screws can't come loose. Make sure that nozzle is tight. Make sure it is also vertical. If your nozzle gets bent even a little bit, it can cause issues like this. And if you haven't done the eddy sensor upgrade on the SV08, we recommend it because it gets rid of a lot of the bed leveling issues that you see on the SV08s. Moving on to supports not supporting. They're having issues with supports not doing a darn thing. You usually have a few that fail here and there, become blobs, but at the point it needs to support, the printer adds them in thin air because, like the creep, support finds a way. They're warning me it's a settings issue. Things are a little bit difficult to remove. So let's take a look. So yeah, definitely our supports have gone missing, right? We can see where the printer kicked it off. Totally fine. Let's take a look here. We're in Orca. We're using Tree Auto. I'm more of a manual person. I like to manually paint my stuff. I'm not a huge fan of just letting the slicer decide what's critical. I like to decide what's critical, but again, that's up to you. Top Z's distance of 0.17, probably gonna be a little tough. Your base pattern of hollow, I can't always recommend. Just set that to default. It should be fine at default. But everything else here seems to be fine to me. The thing I want to point out, though, is that Z-hop is always a concern. I understand that, yes, it looks like top commenter said that their Z height needs to be lowered a little bit. I don't disagree with that. It does look like it could go a little bit lower, but let's learn to properly support 3D prints. If you guys want like a video on manually supporting a 3D print, let me know. And if you're in our Discord, let's just have you guys submit some different files for FDM printing where we can support them as part of the video so we can kind of show what we would do versus what the slicer would do versus what everything does, right? And that way you can kind of get an idea of how to better optimize your material usage while at the same time not risking your parts looking like crap. The decent side of this is that an X-Acto knife and some sandpaper solves this entire problem. This looks to be more of a cosmetic part than a functional part. So if you just clean up that bottom edge by sanding it, I think the bulk of the problem goes away. I recognize it doesn't solve the printer problem, but it's a good thing to know that you can always just post-process the prints to make them look prettier. But we can see that there's just more inconsistencies on this machine that I'm not all that happy with personally. Where I look at this and say, I want this to look better. And there's a lot going on that could cause it. So a couple of things. One, I want to see some Z-hop. Tree supports, organic supports, whatever you want to call them, are the most common to get knocked over by a fast-moving hot end. I understand that Z-hop can add some zits and stuff here and there. There are ways to mitigate that. If your nozzle is drippy, go see a doctor, okay? Or add some retraction, whatever works. But a little Z-hop goes a long way in making sure that you can avoid your parts. We've talked about this before, and we get a lot of people that push back in the comments about it. And while I understand that for some people, this is a non-issue where they've dialed things in where they don't need Z-hop, and hey, I'm proud for you. Personally, I'm not risking even the minuscule amount of time increase and the potential for a slightly worse surface finish to have supports that get knocked over, the nozzle running into the parts, just all these potential problems that can arise from nozzles colliding with things they shouldn't collide with. So let's start there and see where that gets us. From there, we can look at adjusting our extrusion multiplier. I see some blobs here and there. We can look at some of the other settings that exist, but let's just start. We can get that Z height a little closer on that first layer, that's fine. But I definitely want to work on getting that contact distance set correctly, making sure that Z-hop is there, and let's look at painting our own supports where we think it's needed, and not just trust a computer to do all the stuff for us. We all don't survive because an AI says we should survive. We survive because, for the most part, we know how to take care of ourselves, regardless if we actually do it or not. So let's not rely on a computer to do this for us. It's a very easy skill to learn and very, very valuable when you're looking at doing really big parts where you say, it doesn't need support there, and you can save a bunch of extra time. Or when the computer says it doesn't need support, then you say, yes, it absolutely does. You can go ahead and add it when it makes sense. I think it's a useful skill. I'd love to know your thoughts down below. This one's a fun one for me. I heard it, and before I even looked at the comments, I knew exactly what it was. Let me know what you think. Listen to this little bit, pause the video and comment. No cheating. Did you hear it right there at the end? You hear it? That's pretty funny if you ask me. So, what do you think it is? You have both a 3D printer and a flute. Your printer's literally whistling because of the air running through the gyroid infill. Yeah, it's a funny one. It doesn't happen very often, but when it does, and it hits that note that you can hear, it's like, what the actual heck was that? And you can sit there and go crazy because it's not consistent. It doesn't line up with anything that makes sense. And your first thought isn't the fan that's hiding behind the printer pushing air into the infill that is creating a whistling noise. Thankfully, it's not belt tuning. Thankfully, it's nothing that is that big of a deal. It's a win at the end of the day, and you get to enjoy your printer singing you the song of its people. The first time this happened to us, absolutely had no idea what it was. Threw me for a loop for days. And then I was really just watching it really closely, and I put a piece of paper underneath the fan and it stopped. I'm like, oh my God, the freaking infill is whistling. It happens. This is one of those things where you think it's a problem, it's not, and it's the win of the century as far as I'm concerned. As far as I'm concerned, the names listed right next to me, the $5 tier and higher, are awesome people that help make videos like this possible. Huge thank you to all of you. And if you want to come hang out in our Discord, it's the $10 tier and higher. Yes, it's pay gated. There's some good reasons for it, especially if you're running a small business. We give you a lot of one-on-one help. We do quite a few hangouts a week. That is all we have for you all today. Stay safe out there. Don't forget to call your lovers. Don't forget to leave a like and get subscribed if you enjoyed this kind of thing. And as always, keep making awesome. Have a good one.